All right, guys, like I mentioned, we're still going to be working with trigonometry, and so we're still going to be using SOHCAHTOA. These are things you should probably already have starting to have memorized or think about, and so I have them up in the background so I can always point to them and refer to them. But remember, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. And those are going to be important as we move through our day to day and the rest of this chapter. So start kind of banking those in your head. Today you're gonna need a calculator. And again, the other day and as we warmed up today, I was kind of asking you a few things and working with your calculator. I don't care if you're using a calculator. I don't care if you're using Desmos. I don't even care if you're using Desmos on your phone as through the your internet on your phone, or if you've downloaded the app. It is very, very important. So at any point today, if I say this is what you should get on your calculator and you don't get it, remember I'm waiting in the Google Meet that you can pause your video, go to the Google Meet and say, Miss Jabs, I'm not getting what we're supposed to get. Can you please help me figure out what's going on my calculator? And I will very easily be able to help you figure out what's going on your calculator. So just make sure it's in degree mode. So again, on Desmos, you click that little wrench, and at the bottom, instead of radians being highlighted in green, click on it so that it says degrees highlighted in green. All right, so here is today's lesson, 8.2, solving for an unknown side. Okay, so guys, since we're solving for an unknown side, all of our answers should go to the tenths place. So always round. Your calculator is going to give you a big, long, crazy answer. Please round to the tenths place, always. Okay? Please remember we're going to need to be using SOHCAHTOA as we work forward. And so our triangles are slightly going to look like yesterday, but there's not going to be numbers around all of the triangle. There's only going to be one number, there's going to be one variable, and there's going to be one side that is blank. Now, in all reality, all three of those sides are important, and it's still going to be important for us to label hypotenuse, opposite, and adjacent. Because without knowing those things, we're not going to know, should I use sine, should I use cosine, or should I use tangent? So I'm going to hold up our first example, because that's all we really can do right here besides saying, hey, we're solving for a side. Let's use SOHCAHTOA and go to work, okay? So here's your first example. Again, I'm going to hold it up real quick, but then I'm going to move it down and start talking a little bit. And again, I've got colors here to help us out, to help us see things. So here's your first example. Call it example 1 and copy it down, please. So obviously, we're solving for x. Okay, we're solving for x. We're trying to figure out what is the length of x. Now, in order to know the length of x, again, this is why I went so long yesterday, we need to know opposite, adjacent, and hypotenuse. Now, the other day, the problem told us what angle to look at. But if you look at this problem, there's really only one angle given. In this triangle, it's 57 degrees. So 57 degrees is the important angle, the angle we need to worry about. So I would like you, please, it is helpful in my opinion, if you circle 57 degrees. So we've circled 57 degrees. We need to figure out my words hypotenuse, opposite, adjacent. Remember, hypotenuse deals with the right angle. So I'm going to find my right angle. That's right here. I'm going to go across from it. So 25.1 is my hypotenuse. So I'm going to write HYP right next to that number 25.1. Okay? So we figured out my hypotenuse. There is a value there. That's going to be important in just a minute, but don't worry. We want to find and label all three sides. So remember, 57, since that was the number that was given, is the important angle. And so I'm going to go across from it. And across from it is our word opposite. Across equals opposite, remember. Across equals opposite. And yes, the other day a couple of you were like, Miss Jabs, when I was working on the homework, a couple of you asked me some questions either before or after when you were working on it. You're like, well, 57, this is actually next to 57. I realize that, but remember we already wrote the word hypotenuse there, so we're not going to write another word there. So my hand is covering it up. What is the only other leg that is next to 57? It's this one right here. Now I'm about to say something that is very, very important. Okay? If we look next to hypotenuse, there is a number there. Okay, that's very, very important. So I'm going to circle that because that's very, very important. Sorry, I just changed my mind. I'm going to put a box around it. That is very, very important because there is a value there. We're trying to find x. So since x and opposite go together, I'm going to put a box around them. They are very important. It is important that I label this side, but if you notice, this side is blank. So that actually means in this triangle, the adjacent leg is not very important to us because it doesn't help us. There's nothing there. And since there's nothing there, it won't help us out. So I'm going to cross that out. So would you agree I did label hypotenuse, opposite, adjacent? I did label all three, but I figured out that one of them was not important. That means there's only two important legs. What two legs are important in this triangle? Opposite, hypotenuse. So let's go over here and figure out which of these ratios is the one that says opposite and hypotenuse. And so in order to solve example 1, I am going to have to use sine. So I am going to rewrite exactly what I have on the board behind me so you guys kind of know where this comes from and you know what we're supposed to do, okay? So we realized by our triangle and what legs we had that we're supposed to use sine. Sine of theta. Remember theta, and again, you can come back and listen to this. You might want to write this on your paper. Theta is our angle. Which one of these numbers is the value of the angle? All right, 57. So let's go ahead and write sine of 57 degrees equals what? It's a trick question a little bit. What is the value of my opposite leg? Oh yeah, that's the one I don't know. That's x. So I'm going to write x in the numerator. What is the value of my hypotenuse? So in the denominator, I'm going to write 25.1. Now, this should be an Algebra 1 problem, besides the fact that sine of 57 is kind of something weird. It's okay. Our calculator can figure it out. If we were in Algebra 1 class and you had x divided by 25.1, how would you get rid of that divide by 25.1? Yep, multiply both sides by 25.1. Sorry, I'm really close to the edge of my paper. And so on the left, it's my fault, on the right side, the 25.1 cancels out. On the other side, and this is one of the times, our calculators are very picky, and different calculators work in different ways. But it looks like we have to take 25.1, times the sine of 57. A lot of calculators will allow you to type it in this way. And I know when I hold up my phone, there is a glare on my calculator screen sometimes. So I try to look at it to make sure that it doesn't show the glare when I do this. Desmos is really, really smart, as are those TI-30 calculators. But can you see right there how I just typed in exactly what I have written on my paper, 25.1 sine of 57? And so my long answer would be 21.0506312. Okay, if you are not getting that answer, and you don't have to be using Desmos, okay, you do not have to be using Desmos. That should also be the same answer on your regular calculator. You should get 25.05, but that 0.5 means I should round up to 0.1. So 21.1, and since I rounded, sorry, I goofed up at first, I should actually probably use that little squiggly equal sign to say approximately equal to. So guys, as we go on, I'm not going to spend as much time. I just spent about 5 to 7 minutes on example 1. My next few examples are not quite going to take as long because I'm hoping you're able to kind of start labeling the 3 sides, figuring out which one is not important, plug in, and then just type it in your calculator and it helps you out. So here's example 2. You might want to pause it long enough even that you label your 3 sides before I do. So again, you can always rewind and do more work, but I'm going to label all 3 sides 43 degrees is my important angle. Circle it. Go across from the right angle, right HYP. Go across from 43, right opposite, OPP. Go next to 43, right adjacent, ADJ. Once again, if I am doing this too fast, you need to pause your video, click over to the Google Meet, and talk to me. Thank you. So it looks like I have figured out that X is my opposite, and that is unknown. That the adjacent is 7.1, and I know that value. There is absolutely nothing along my hypotenuse leg, so I'm going to scribble out hypotenuse because it's worthless to me. That means I need to look for my problem that has adjacent and opposite. So which one of my trig functions has adjacent and opposite? Thank you. I need to pick tangent. So again, on my paper and on your paper, I would strongly recommend just writing tangent of theta equals opposite over adjacent. And then we're going to look through. Theta, again, represents my angle. In this problem, what is the answer for the angle? What is the value of the angle? It's 43 degrees. Thank you. What is the value of opposite? Oh, yeah, that's what I don't know. What is the value of adjacent? 7.1. Sorry, guys, I was saying 43, and I accidentally kind of made it look like more like a 5, so I had to rewrite it. Tangent of 43 equals x divided by 7.1. Uh-oh, our unknown is divided by some number. Let's get rid of that 7.1 by multiplying both sides by 7.1. And so, again, if we're very careful about how we type in our calculator, we should type in 7.1 times the tangent of 43. By the way, if you're using Desmos to get tangent or sine or whatever, you can either use the alphabet thing and type in SIN or TAN or COS. It will know what you mean. Or if you're using your phone like I am, there's this function button right here. And if you click on function, it usually pops up and there's all your trig functions right there, and just select what trig function you need. And so x should equal 6.62. The 2 tells us to keep the 6 rounded down to a 6. Thank you very much. There you go. So ladies and gentlemen, I didn't write this on here before, so I'm going to do it now. Since I did those two, this example will follow very, very clearly, but you must hit pause right now, copy down the triangle, and then click over into the Google Meet and work on it with the Google Meet with me. And I will confirm if your answer is right or not in Google Meet. So here you go. Copy it down and come find me in Google Meet. All right. So I'm not even giving the answer for example 3 right now, because example 3 you will find out if you were right or wrong in Google Meet. So I have a couple things to talk about here. If you notice, in those first 3 examples we did, our unknown was always in the numerator, right? We had 47, sine of 47 equals x over 36.3. And by the way, I would say, how would you get rid of this 36.3? And you would always say multiply, 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 multiply. If you look at example 1, 2, and 3, we always multiplied. So I have a big hint for you to write down. You don't really need to write this down, this example with these numbers, because that's not always what it's going to be. But if your unknown is in the numerator, I promise you, you will multiply to solve that problem. If your unknown is in the numerator, you will multiply to solve that problem. So just a minute ago, here's the example. We did 7.1 times the tangent of 43 degrees. The other example we did before that, we did 25.1 times the sine of 57. When your unknown is in the numerator, you automatically are going to multiply to solve. That's a very important note. I would make sure to have it written down, so rewind if you want. Now, I'm going to spend a little bit of time on this because we haven't seen it yet, but I promise the next example is going to have it, and so it's going to help us to do this before. What happens if our unknown is in the denominator? All right, at first, would you copy down only this problem? So, people always get a little bit tricked up on this one, so I'm kind of happy I can teach this on video because nobody will interrupt me. The first thing we actually need to do is get that x out of the bottom. So to get that x out of the bottom, I'm going to multiply both sides by x so that that denominator cancels out and my denominator is completely gone. All right, so right now I'm now going to have x times the sine of 41 degrees equals 18.6. But remember, I'm trying to solve for x, so I want to get it by itself. So I'm going to divide both sides. It's weird to think of this, but I'm going to divide both sides by that whole thing, sine of 41. All of that is together one thing, and all of that should show up in the denominator. Would you guys agree with that? All right, so it's going to make it easier to see. I'm going to pick up the black again, and I'm going to write x equals 18.6 divided by the sine of 41 degrees. Okay, I have another problem. By the way, these were just made up. What if we had started to do our work and we were supposed to use cosine of 85 degrees equals 13.5 over x? Uh-oh. Divide by x. I don't like that. Let's multiply both sides by x. That cancels out the x. But now I have x times the cosine of 85 degrees equals 13.5. And remember, I don't want x times the cosine of something. I want to just have x, so I'm going to divide both sides by the cosine of 85 degrees. Because then the cosine of 85 degrees will cancel out. And again, in black, I'm going to write my answer. X equals 13.5 over the cosine of 85. Now, I know I did that work in pink, but I would like you to pay attention to the original. Do you see how the original, written in black, says sine of 41 degrees equals 18.6 over x? But when I did some work, my answer ended up having x on this side where the sine was, and sine in the denominator where x was. The 18.6 still stayed in the numerator. Same thing on this side. I started out with cosine of 85 by itself on this side. It ended up just being x on this side. I had 13.5 in the top. It's still in the top. But the cosine of 85 degrees suddenly moved to the bottom. So 2 seconds ago, a little bit longer, I said if your unknown is in the numerator, you're going to multiply to solve your answer, to find your answer. But I have a new thing to write. Notice when our unknown was in the denominator, we kind of had to flip a few things around. And so I'm going to call this the swap. Would you please look at this first example? Sine of 41 equals 18.6 divided by x. If I just put a little swoop arrow like that, would you agree that kind of tells me to switch those two spots, swap those spots, and that's what I would write. Then we don't always have to do this work in the middle. Look right here. Do your little swap. So I'm going to say this on the next example because I know it's coming up. And if you swap those two, guess what you get? And so would you please write this down? If my unknown is in the denominator, I'm going to swap spots, and therefore I will divide to solve. If my unknown is in the denominator, I'm going to swap spots, and therefore I'll divide to solve. All right, so we got 2 more examples to get through. I'm going to hold it up. You're going to hit pause, and as soon as I move the paper down, I'm already going to label my 3 sides of opposite, adjacent, and hypotenuse. And so I hope you do that as you pause. So hopefully, if you need to review a little bit, remind a little bit because you didn't do it. 35 degrees is my important side. I'm going to go across from the right angle and label hypotenuse. I'm going to go across from my 35 degrees and label opposite. And I'm going to go next to my 35 degrees and label adjacent. But if I do that, ladies and gentlemen, the hypotenuse has x by it. The opposite has 12.7 by it. The adjacent has nothing by it, and therefore it's not important. And so SOHCAHTOA, I need to use opposite and hypotenuse. Thank you. I'm going to use sine. And once again, it is always helpful, especially when we're brand new at this, that we write sine of theta equals opposite over hypotenuse. So let's look through this triangle. What is the value of my theta? Thank you. It is 35 degrees. What is the value on my opposite leg? Yep, you got it, 12.7. What is the value of my hypotenuse? That's the one I don't know, so I'm going to write x. Guys, What do I do if my unknown is in the denominator? Good. I swap my spots. So I'm going to swap spots right there. I always like to draw that. You guys will probably see me do that lots of times. So that means I'm going to write on my answer, to get my answer, 12.7 divided by the sine of 35 degrees. And once again, if you're using Desmos, to get divided by, hit that button at the top. I think you guys know which one it is. It's going to make it look like a fraction automatically. And if you're using Desmos, it's going to make it look exactly how I have it written right here. Except it usually puts the trig function in parentheses. So right there, if you can see it, 12.7 divided by the sine of 35. Remember, because we're in degree mode, that's why we don't have to put the little degree symbol on there, equals 22.14177. Keeps on going a little bit, but it looks like my answer should be 22.1, because that would round and stay as a 1. And so my answer for example number 4 is about 22.1. All right, guys. Thank you very much for working on this and watching this. I know some people want to review and watch more, and that's okay. But example 5 is a lot like example 3. You're going to copy it down, go back to the Google Meet, work on solving it kind of live with me while you're there. And then if both and all of the examples seem to make sense, the homework's going to be posted and you should be able to work on the homework. Please remember the homework is due at 10 o'clock today because our class goes from 8:30 to 10. So kind of keep an eye on the clock, please. Here is example 5. After you get it copied down, go ahead and hit pause and come find me on Google Meet.